The reciprocal family function. First, let's define an asymptote. An asymptote is a line that a graph approaches as you move away from the origin. So we have three different types of asymptotes below. A horizontal asymptote would be this green line. So our red graph, it slowly approaches that green line, but it's never actually going to touch the green line. That's how we describe an asymptote. So this is a horizontal asymptote. We also have vertical asymptotes. So likewise, the red graph, it'll slowly approach it and it'll get really close, but it's never actually going to get to that green line. And then lastly, we have an oblique or a slant asymptote. And this just refers to any line that's going to be an asymptote, but it's not going to be horizontal or vertical. So whether it has a positive slope, negative slope, it doesn't matter. It's just not going to be horizontal or vertical. When we're graphing simple rational functions, we're working off of the parent graph y equals 1 over x. And this is what it looks like. We have a vertical asymptote at x equals 0, a horizontal asymptote at y equals 0, and those are marked with the dotted green lines. And then the actual graph y equals 1 over x is represented by the red lines. So as you can see, it's split up into two sections, but it'll go very close to the asymptotes, but it's never actually going to reach those points. So when we're listing the domain for this graph, this fancy R stands for all real numbers. So the domain is going to be all real numbers except for where x does not equal 0. So since we have a vertical asymptote at x equals 0, we know that that red graph is never going to have an x value of 0. So the domain is all the x values except when x equals 0. The range, likewise, is going to include all real numbers except when y equals 0. So again, we will hit all the y values except when we have that y value of y equals 0. Since our graph is never going to have an x value of 0 or a y value of 0, we don't have an x-intercept or a y-intercept. As we continue graphing simple rational functions, we want to talk about two different types. The first type, you'll see the function written in the form y equals a over x minus h plus k. And the information we gather from there are the asymptotes. The vertical asymptote is going to be the line x equals h. Now remember, just as we've talked about in equations before when we dealt with transformations, that h in the formula is x minus h. So whatever value we see for h, it's actually going to be the opposite sign of what we see. The horizontal asymptote is going to be the line y equals k. And since in the original equation we have plus k, whatever sign you see here, positive or negative for the value of k, is going to be the same for the horizontal asymptote. Now for the domain and range, these follow just like in the parent graph. The domain and range, they'll both be all real numbers where x does not equal the value of the asymptote. So for the domain, it's all real numbers where x does not equal the value of h. And for the range, it's all real numbers where y does not equal the value of k. Now you'll see in the examples that we work out that I'm also going to ask you for the x-intercept, the y-intercept, and for you to graph at least 4 good points. So to get this information, we're going to take it off the calculator, just like we did before. You're going to graph the function in y equals, and then we'll calculate the zeros of the function. And you can also calculate the value where x equals 0 to find the y-intercept, and use the table to find at least 4 good points to plot on your graph. So let's go ahead and walk through one example. This is a rational function given to us in type 1, so let's go ahead and fill in the information that we can gather from here. The vertical asymptote is going to be x equals h. So remember, this is h with the opposite sign of what it looks like. So we have the equation x equals positive 3. The horizontal asymptote is going to be y equals k. Our k is a positive 4, So our horizontal asymptote is y equals positive 4. The domain is all real numbers where x does not equal h. So we have all real numbers where x does not equal 3. And for the range, all real numbers where y does not equal k. So we have all real numbers where y is not equal to 4. Let's go ahead and plot these on our graph. So we have a vertical asymptote at x equals positive 3. So I'm going to go ahead and graph my vertical asymptote, and a horizontal asymptote at y equals positive 4. So here's my horizontal asymptote. So we know that when we draw on our graph, it is not going to be able to cross those lines. When you use your calculator to select 4 good points to graph, the points that you'll find in the table are positive 1, positive 3, positive 2, positive 2, and then positive 4, positive 6, and positive 5, positive 5. So in addition to these 4 good points that we have, we want to find the x-intercept and y-intercept from our calculator. So when you find the x-intercept on your calculator, you'll find that it should be 2.5, 0, and the y-intercept will be 0, 3.3 repeating. So we can also go ahead and plot those. So we have 2.50 for our x-intercept, and then 0, 3.3 for our y-intercept. That's going to be around here. So these points are just going to help us sketch the points that we have along with the asymptotes, because we know that it needs to connect those points, but it's never going to intersect the asymptotes that we have. So go ahead and sketch your graph like this. And so we have all the information that we need and the sketch of our graph.